Welcome to Crosstalk Solutions. My name's Chris, and we finally have one of the new Wi-Fi 6 access points from Ubiquiti Inc. right here in my hands. This is the UniFi U6-Lite, model number U6-Lite-US. The MSRP on this access point is $99, and this is one of two Wi-Fi 6 access points from Ubiquiti Inc. that is currently available outside of the early access store as of the recording of this video. The other one is the long-range version, the LR version of the UniFi 6 AP. So this access point is Wi-Fi 6. That is the 802.11ax Wi-Fi standard. You might hear someone say Wi-Fi 6. They might say 802.11ax. They might say high efficiency wireless. All of those mean the same thing, and it's the new Wi-Fi 6 standard. And they just call it Wi-Fi 6 because Wi-Fi 6 is much easier to say than 802.11ax. Online, this device says that it has an aggregate throughput of 1.5 gigabits per second, but that claim is actually a little bit misleading because no single device would ever get 1.5 gigabits worth of throughput out of this device. First and foremost, it only has a gigabit physical network connection on the access point itself. When they say 1.5 gigabits of aggregate throughput, they're talking about 1.2 gigabits of throughput total in the 5 gigahertz band. It's a 2x2 multi-user MIMO 5 gigahertz, or 300 megabits per second in the 2.4 gigahertz band. And for 2.4 gigahertz, it has 2x2 MIMO capability. So you take the 300 megabits of 2.4 gigahertz and the 1.2 gigabits of 5 gigahertz, and you slap those together, and basically if this thing was completely maxed out with clients in both 2.4 gigahertz and 5 gigahertz, you would have a total of 1.5 gigabit per second capacity. But again, considering that it only has a gigabit NIC on the device itself, you're never going to see those speeds, not even really in a perfect environment. Now, there are many advantages of Wi-Fi 6 over Wi-Fi 5, which is the 802.11ac standard. Really, I'm going to do a completely separate video on Wi-Fi 6. That's how many improvements there are over Wi-Fi 5. However, the improvements in Wi-Fi 6 are less about speed to a single client and more about overall capacity in dense environments. So basically, Wi-Fi 6 increases efficiency and capacity when you've got a ton of clients connected to your access points. Okay, so I have a lot of people ask me, is it worth upgrading to Wi-Fi 6? And to answer that question, I would say it depends, right? How dense is your wireless environment? How many devices are on your network? And that's going to really make the difference for you. Because if you have just a standard home with, say 20 or so different devices, TVs and Rokus and Nintendo Switch and PlayStation and, all of your laptops and iPhones and iPads, maybe you've got like 20 or 30 of those devices at home, Wi-Fi 5 is still going to be just fine. Like, you're not going to see much improvement for Wi-Fi 6. But if you have 50 or 100 devices, IoT devices, and everything's trying to compete for the same, radio frequency bandwidth, then you might see an improvement with Wi-Fi 6. So what I would recommend is if you're coming from something older than 802.11ac, it's probably worth upgrading if you're thinking about upgrading anyways, or if you don't have access points at all, maybe you just have the one that came with your ISP and you want to implement a real wireless network, a quote unquote real wireless network, I would say at that point it's worth investing in Wi-Fi 6 instead of the older generation Wi-Fi. All right, so let's take this thing out of the box and talk some more about some of the specifications of the U6-Lite access point. All right, so here's the U6-Lite-US. MSRP is $99 on this unit. Here we have some mounting hardware. Here's the access point itself. Beautiful, look at this. So it has this nice plastic case, or covering I should say, and it says right there, UniFi 6. Look at that, that is just absolutely gorgeous. One thing to note is this is the exact same form factor as the Nano HD access point, so the Wi-Fi 5 Nano HD. So not only can you use the same mounting bracket as the Nano HD, here we have the same mounting bracket, but you can also use the Nano HD skins on this U6-Lite. So you get the mounting bracket, the access point itself, and you also get the drop ceiling mounting bracket. All right, so let's take a look at this device a little bit closer. On the back side, really not much to it. We have a gigabit Ethernet port, and then we also have our standard reset switch. This device can be powered by either 802.3 AF PoE or 48 volt passive PoE. It has a maximum power consumption of 12 watts. And if we're talking about antenna gain, it's 2.8 dBi for the 2.4 gigahertz antenna and 3 dBi for the 5 gigahertz antenna. The operating temperature of this device is actually pretty impressive. So for operating temperature, it can go from -30 to 60 degrees Celsius, which is -22 degrees to 140 degrees Fahrenheit. Now, keep in mind though, this is not an outdoor rated access point. Notice that there's no plastic covering, or they have like those rubber grommet coverings for the, how's this thing go on here? There we go. Usually you'll have like for the UAP-AC-Pro, for instance, there was like a rubber sort of, covering or insert that went in right here that helped keep it a little bit watertight. This one does not have any such thing. So while it does have some pretty extreme operating temperature capability, it's not actually an outdoor access point. But like, I wouldn't have any problem sticking this thing up in my attic, which is actually probably where it's going to end up living once I am done with the testing here. On the product page for the U6-Lite, Ubiquiti also recommends two different types of mounting, right? So you've got mounting from the ceiling, sort of top down, and this is for more dense environments. If you have a lot of clients connecting to this device, top down is the way to go. Or you can mount it sideways, vertically, on the wall if you are trying to extend the range of the access point. So for instance, if you have it on one side of your house and you want to sort of extend the range all the way through your house, you're going to get more range out of this device by putting it on the wall facing the way that the direction that you want the range, as opposed to having it right on the mounted horizontally on the ceiling. Now, what I typically recommend is to have these access points as central as possible. So if you have a house with just one access point, try to get that access point like in the center of the home somewhere and as high up as you can go. So like if it's a 2-story home, center of the home on the 2nd story, facing down to sort of cover the entire home. If you have 2 access points, you'd want them on sort of, take the house, divide it in 2 halves and put it in the center of each half facing down. But again, your results may vary. It also depends on what type of building materials your house is made of, and et cetera, et cetera, et cetera. It's really hard to determine or give a definitive answer that will suit everyone for like best access point placement. So if you're not sure, then I would say mount it temporarily, horizontally or vertically, and see how it works, right? And if it doesn't work as well as you want it to, try it the other way. All right, so now let's get this Wi-Fi 6 access point adopted into UniFi. I'm going to sort of set it up in a test environment, and then we're going to start putting it through its paces with multiple Wi-Fi 6 clients. I actually have a lot of different Wi-Fi clients that we're going to use for testing this device, because again, Wi-Fi 6 isn't about increased speeds to a single client. Wi-Fi 6 is about increased aggregate speed to all of your clients and devices combined. All right, I have the U6-Lite plugged into one of my Gen 2 Pro switches, which is connected to a UDM Pro. I am currently running UniFi version 6.0.41. And once we're in UniFi, if we come over here and click on Devices, we now see a U6-Lite that is pending adoption. So let's go ahead and click Adopt. And we are now connected. It took about 1 minute to adopt. I have a solid blue light on the access point, and let's see if we do have an upgrade. So let's see, it came to me with version 5.43.14. Let's go ahead and upgrade it. And it will upgrade, it looks like, from 5.43.14 to 5.43.19. So we're going to go ahead and run the upgrade now. All right, there we go. We have now upgraded to the latest version of firmware. We are back to a solid blue light. That took about 2 to 3 minutes to perform that upgrade. In order to properly test Wi-Fi 6, I wanted to create an environment with multiple clients that I could use to test Wi-Fi simultaneously. And I'm not setting this up to be like the perfect Wi-Fi 6 test environment. I wanted to set up more of a real-world type scenario. So let's take a look at my Wi-Fi 6 test network. Here we have the internet coming into a UDM Pro. All of the devices here are using the latest and greatest software and firmware. The UDM Pro feeds into this USW Pro 24 PoE switch. That is the Gen 2 24-port Pro switch, which has the 10 gig SFPs. The reason that I wanted to use 10 gig SFPs is because I have this server right behind me that has been configured as a TrueNAS server, and it has a 10 gig NIC included in the server. So I have a 10 gigabit connection between this server and that 24-port Gen 2 Pro switch. The TrueNAS server is going to serve two separate purposes. First and foremost, I have about 30 gigabytes worth of files sitting on a share on an SSD on that system that the wireless clients are going to be pulling down from the file server over the network, which is why I wanted as much bandwidth as possible for this server so that the disk speeds and the onboard NIC of the server are not a bottleneck in my Wi-Fi testing. The second purpose for this server is as an iPerf server. So with TrueNAS, you get iPerf built in if you drop to a shell. And so if I run an iPerf command, here we can see this is from my desktop computer, which is currently wired directly into that switch. And it looks like we're pulling about 940 megabits per second between my computer and that switch. Of course, the limitation there is not the NAS server. The limitation is the 1 gig NIC that I have in my own PC. Okay, so TrueNAS is not going to be a bottleneck for serving files. The other things that I have connected into this switch are, of course, the U6-Lite access point, which is actually just above this painting right here on the wall. And then also connected into that switch, I have my QNAP QGD 1600P. That is a PoE switch / virtual machine appliance in one. Check out my video on the QNAP QGD 1600P if you're interested. On that QNAP server, I have two things. First, I have an Ubuntu 20.04 virtual machine that is strictly there for running Ansible. By using Ansible, I can control my Ubuntu clients simultaneously and basically do one central command that tells them both to start downloading files through Wi-Fi from the file server. Also on the QNAP QGD 1600P, I have an OpenSpeedTest Docker container so that I can run OpenSpeedTest tests over the network, not having to use an internet-based speed test because my internet connection is only about 400 or 500 megabits, right? So theoretically, the speeds on the access point are going to be able to do far greater than speeds out to the internet in my case. So here we can see what OpenSpeedTest looks like. This is an HTML5 based application. If I hit start, we will see what kind of speeds I can get between my computer, which is hardwired into that Gen 2 switch, and looks like we are getting very close to the maximum throughput of my machine, which is, it's got a 1 gig Ethernet port. Yep, so there we go. We can see I got 985 down and 983 up. So basically full gigabit speeds between my computer and that speed test. The speed test itself is not going to be a bottleneck. Okay, so that is my test network. Let's talk about the clients. I'm using 4 different clients in total. The first one here is Ubuntu 20.04 running on a really old PC. This is an old AMD A4 3420 with 6 gigs of DDR3. I did upgrade it, however, with a 120 gig SSD because, again, I don't want a mechanical hard drive to be any sort of bottleneck in the speed testing. Inside that computer, I have a TP-Link Archer TX3000E Wi-Fi 6 PCIe card, and that is an Intel AX200 based Wi-Fi 6 chip. On my own computer here, my desktop is running Windows 10. It is an Intel i7-8700K with 32 gigs of DDR4, and my drive that I'm doing testing on is a Samsung M.2 NVMe drive. In my system, I forget the exact brand that I have, but I have also an Intel AX200 based Wi-Fi 6 PCIe adapter. Okay, so then my other two computers. One is up in my attic. So I didn't want to do anything where all of my computers are in the same room with perfect line of sight to the Wi-Fi 6 access point. One of my systems is literally sitting up in the dark in my attic, about probably 30 to 40 feet that direction, and it's going through drywall, it's going through the framing of the house, it's going through insulation, it's going through HVAC ducting. It's not an ideal placement for a Wi-Fi testing server, which is exactly what I wanted. That server is running Ubuntu 20.04. It's also a rather old PC, but not super old. It's a 4th gen Intel i5 4690K with 8 gigs of RAM. I also upgraded that system with an SSD. It has a 500 gig SSD. So I'm not using a brand name Wi-Fi 6 adapter up in that system either. It is a U-bit Wi-Fi 6 adapter, which is just, again, another Intel AX200 based Wi-Fi 6 PCIe card. One note about the PCIe cards, I had a heck of a time when I was first setting up this test environment because I have a lot of systems that have micro ITX motherboards, and the micro ITX motherboards typically only have a single PCIe X16 slot. One thing that I found out after about 3 or 4 hours of troubleshooting is that the Wi-Fi 6 cards really only work in PCI X1 slots, or I should say they're recommended for X1 slots. You can also get them in some of the other flavors in between X1 and X16, but the really high-speed PCI bus, the X16 PCI bus for like graphics cards are not good for the Wi-Fi 6 adapter. So I tried it in both Windows and Ubuntu on a mini ITX motherboard that only had a single PCI X16 slot, and it would not work. The system would detect the card, but it was not able to initialize the card. I had the same exact problem in both Windows and Ubuntu. So if you're setting up any sort of Wi-Fi 6 test environment, make sure you're not using PCI X16 slots for your Wi-Fi 6 adapter. The final system that I have, some of you guys might recognize if you watch the channel. This is a Lenovo desktop. This is the one that I bought at Costco a few weeks ago when I was looking for a Wi-Fi 6 test machine. I ended up keeping it because I didn't have enough machines when I had to rule out all of my mini ITX machines. I decided to just keep this one, and we're just using it as a Windows 10 desktop. Right now, it's being used to test Wi-Fi 6. That is an Intel i5 10th generation 10400 chip, 16 gigs of DDR4, and it has a 256 gig M.2 NVMe drive. All right, there we have a look at the full test environment. If you guys have any suggestions for how I can improve this test environment, make sure you put those down in the comments below. But let's move on to the actual testing. So I ran a number of tests, and I did them with each computer individually. I also did some tests of all of the computers pulling data through the network simultaneously. And I also wanted to pit the U6-Lite up against a different Ubiquiti access point. And so I chose our old standard. Okay, so this is the Wi-Fi 5 or 802.11ac UAP-AC-Pro, right? This is the standard Ubiquiti or UniFi Pro access point from the Wi-Fi 5 series of access points. And man, we have deployed literally hundreds of these over the years. We absolutely love this access point. It's basically been our standard go-to access points for just normal deployments for as long as I can remember. So I felt this would be a good competitor against Wi-Fi 6. So we'll get into the sort of comparisons versus the UAP-AC-Pro in just a little bit. But let's start off by taking a look at our iPerf testing. Okay, so I ran all of these different tests. I ran 5 different iPerf tests. We have iPerf -C and then the client, right? So that's just a standard straight up, no arguments iPerf test. I did the same thing but with the -R flag, which runs it server to client instead of client to server. Then I did another test where I added in 5 simultaneous threads. So that's the -P5. I also ran that same test in reverse. And then finally, I ran a test that was a time-based test of 60 seconds to see what kind of throughput I could get over time. And I ran these tests against each separate computer in my Wi-Fi 6 test network. So let's start with the first one. This is the Ubuntu, this is Wi-Fi 1. That's this system here. It's the old school Ubuntu AMD A4 based processor. And we can see the kind of speeds that we got here. So this is blue on the chart here. This system has perfect line of sight to the access point. It's literally sitting about 5 feet that way, and the access point's about 2 feet above my head right here. Perfect line of sight. And we can see that with this old hardware, we were getting, about 450 or so megabits average. Actually, it looks like 433 to be precise. 433 megabits average between all of these tests. That's the blue line on this graph right here. So it was actually kind of our second best test machine, if you will. The first best was my more powerful Crosstalk desktop. You can see that I got really better speeds in a couple of ways, but the average was lower. So the average for my desktop was lower than for this old school AMD A4 processor, although there's a little bit less line of sight from my desktop because it's underneath this wooden desk. So it did have a little bit of obstruction. It's not pure line of sight, although it is in the same room. It's like about 10 feet or less away from the actual access point. So those two were by far the best. We can see the blue and the yellow lines here. Then we get into Wi-Fi 6-2. That is my i5 Ubuntu-based PC that's located up in my attic. And the speeds that we got for this thing were an average of 222 megabits on the iPerf testing. So going through the attic, going through the insulation and the wooden beams and the HVAC ducting and all that sort of stuff, dropped the speeds down a little bit, but still pretty respectable. We'll see how it stacks up to the same test, but not on the Wi-Fi 6, on the older generation access point in just a little bit. Then we have my Lenovo desktop, and we can see that that one was kind of more all over the place. I got an average speed between all of the tests of about 280 megabits per second. That machine is actually in the next room over, so it's about probably 30 feet away from the access point, through a closed door, through some walls, etc. It's got better line of sight to the access point than the one in the attic does, but it's still not that far. It's still got some obstruction in the way. And we can see the green line here, the Lenovo desktop, was actually pretty slow. 122 down here for this test, 282, 442, 298, and then 259. All right, let's move on to our OpenSpeedTest testing. Now, the way that I did OpenSpeedTest testing is I went to every single machine individually, and I ran the OpenSpeedTest test 3 times. And then I took the average of those 3 runs, and I made that sort of what I put into the graph here. So, Wi-Fi 6-1, the Ubuntu server that's sitting in this room with perfect line of sight to the access point. The download average was 348 megabits. The upload average was 578 megabits. Then we have Wi-Fi 6-2. That is my attic-based PC running Ubuntu. And that was much slower, but also more consistent on the upload and download. About 243 download, 246 upload. My Crosstalk desktop, the one that I'm filming this on right here, got really good results. 653 megabits down, 694 megabit average up. And then finally, the Lenovo desktop, which is a really nice, powerful PC, but it's located in the other room. We got 475 megabits down and 412 megabits up. So definitely seeing some decent speeds here, but we see the best speeds when you're in the same room as the access point, right? If you have decent line of sight to the access point, your speeds are going to be far greater than if you're going through some obstructions, such as wood and drywall and insulation and stuff like that. Okay, so this next test, this was an interesting one, and this is where, to me, I feel this is where the difference is between a 2x2 access point versus, if it was the same access point but 4x4. So for instance, the U6-Lite is a 2x2 multi-user MIMO access point. The U6LR, the long-range version, is a 4x4 multi-user MIMO access point. So we can think of MIMO and multi-user MIMO as essentially like lanes on a highway, right? If you have a 2x2 multi-user MIMO access point, that means you have 2 lanes on that highway, 2 down and 2 up. Most of these wireless cards are also 2x2, right? So they're taking up both lanes. The multi-user MIMO means that they can take up lanes simultaneously, so there's, more efficient communication when you have larger numbers of clients. But if you had a 4x4 multi-user MIMO access point and then multiple 2x2 PCIe Wi-Fi 6 cards in your computers, you're going to get more cars in the lanes, if you will, right? So you can have more total bandwidth available to your clients. When I talk about this U6-Lite sustained throughput test, what I did is I've got 30 gigs worth of files sitting on this file server. It's actually about 3 different files. They're just, movie MP4 files from, videos that I've been creating on YouTube. And I started all of the systems downloading those files simultaneously, right? So 30 gigs of files at, 80 to 50 megabit, right? Somewhere in this range, is going to take a long time to download. So I would start the download, I would let it sit for a few minutes just to make sure, things are now chugging along smoothly. And then I would measure the average bandwidth of each machine as it was downloading its data. For the Ubuntu machine in this same room as the access point, I was getting 81 megabits. For the one in the attic, I was getting 32 megabits sustained. And then for both of the Windows PCs, I just put them at 50 because it's really hard to get an average measurement on a Windows PC. There's a utility called nload that you can use in Ubuntu that, it just makes it really easy to see the average speed of your throughput. Whereas it's not quite as easy to see that. I'm just using like the Windows, task manager, and I just come over here and I'm looking at the, the wireless card and just sort of, gauging the average by eye. So each of the Windows 10 machines was pulling about 50 megabits average. So the total throughput, when all 4 machines were sucking down 30 gigs worth of files simultaneously, drops down to 213 megabits. So that's really interesting to me, right? So for instance, you look at the OpenSpeedTest, and like my desktop was pulling, upwards of 700 megabits doing the speed test to the Wi-Fi 6 adapter. But when there's a lot of machines, even though all of the machines were connected at 802.11ax, there was no Wi-Fi 5 clients in the mix whatsoever. The sustained throughput when they're all downloading files simultaneously dropped way low, right? We came down to 213 megabits per second. And my guess is that the additional overhead of basically scheduling packets to all 4 of those machines as they're trying to download them is what really slowed down this access point. And I'm going to be anxious to test the same test, but with a 4x4 multi-user MIMO Wi-Fi 6 access point, which hopefully I will be getting my hands on soon. All right, moving on to the main event. How does the U6-Lite stack up to the UAP-AC-Pro, the sort of old standard Ubiquiti access point? Let's take a look at that next. Here is our iPerf testing. Now, I broke out these charts into each individual iPerf test that I was running. So let's take a look at them individually. The blue is the U6-Lite access point, and the red is the UAP-AC-Pro. The way that I did this test is I shut off all other Wi-Fi in the house, and then I had one access point or the other up on the wall, basically in the same position for both of these tests. I was pretty impressed by these results. The Wi-Fi 6 access point outperformed the UAP-AC-Pro, even though this is a 3x3 MIMO and that's a 2x2 MIMO, right? So look at this. I mean, we're talking about 450 megabits versus 300 megabits. For the one in the attic, it was actually just about even. For my desktop, again, we saw about a 30% or so improvement with the Wi-Fi 6 access point. And even the Lenovo desktop in the other room, we saw some improvement. Same thing over here. Across the board, the U6-Lite in iPerf speed testing was about 50% faster, 50 to 100% faster than the UAP-AC-Pro. We come down here to the multi-threaded test, and it's the same thing. Wi-Fi 6-1 Ubuntu PC was significantly faster. Same with the Crosstalk desktop, it was about twice as fast, and the Lenovo desktop was about twice as fast. The one in the attic was about the same. Then we have the same test, but server to client, and again, we see the Wi-Fi 6 access point just dragging the UAP-AC-Pro through the mud. I mean, just look at the differences in speeds here. It's pretty amazing. Now down here we have the sustained time-based test, and again, the U6-Lite came out on top again in every single one of these tests. All right, let's look at the OpenSpeedTest comparison. So here we have the download speeds versus the upload speeds, and again, the U6-Lite has definitely beat out the UAP-AC-Pro. I mean, look at the differences here. For something like my desktop machine, it's significant. That's more than twice as much throughput to my desktop versus the UAP-AC-Lite. Same thing with the Lenovo desktop. These are both Windows 10 machines. These two Ubuntu machines over here saw improvement, but not quite as much improvement as the Windows 10 machines. Then we come over here, the upload speed, and same thing. We're seeing almost the same differences in the upload speed as we are in the download speed. Finally, we talked about that sustained throughput test, right? That's where I use Ansible to start file copies on both of the Ubuntu machines simultaneously, and then I went to each of the Windows machines and I started the same file copy. We're trying to pull like 30 gigs worth of files from the file server through this one access point to 4 different clients simultaneously. And we can see here that the sustained throughput of the UAP-AC-Pro was about 164 megabits per second, versus the U6-Lite running that same test was 213 megabits per second. Okay, so again, the sustained throughput test with all of those clients downloading files simultaneously, the U6-Lite still won out over the 3x3 MIMO UAP-AC-Pro. So I was really impressed with that. I thought that it would be maybe dead even with the UAP-AC-Pro, but no, the Lite access point basically blew the doors off this thing. And so it also made me excited for the LR and the other, Wi-Fi 6 based access points that are coming out that have 4x4 multi-user MIMO. I cannot wait to test those now to see how much those stack up against even this U6-Lite. So really impressed by all those speed tests, and honestly really impressed by the U6-Lite. It's a great little access point for $99. Would I recommend upgrading to the U6-Lite? That's the real question, right? And I think it's worth an upgrade if you are ready to upgrade, right? So if you were going to be buying into Ubiquiti for the first time, I would definitely start off on the Wi-Fi 6 stuff. Don't wait, right? Go ahead and get the Wi-Fi 6 stuff. If you have older access points that are, 3 to 4 years old and you're looking to replace them, I would now replace those with the Wi-Fi 6 based access points, right? You might want to wait for some of the other models to come out, but again, what I'm seeing with this U6-Lite so far, I'm really impressed by the numbers. And again, Wi-Fi 6 technology is just much more efficient in denser environments than any of the predecessors. And that's kind of what it all boils down to, right? So feedback. Let me know what you guys think. What do you think about these tests? Do you want me to make these test results public where you guys can sort of look through them? Let me know in the comments below and I can do that. Also, what suggestions do you have for improvement of these tests? I have other devices that I need to test, and I want to start taking a running log of all of these different, access points that I'm running these tests against, so that we can, compare and contrast, over time as new access points come out. All right, so that's going to do it for this video. Hope you guys enjoyed it. If you would like to see more videos like this, make sure you hit subscribe, and if you enjoyed this video, give me a like down below. It really helps out the channel. Okay, that's going to be it for the U6-Lite. We will see you guys in the next video.